So in this video, we're going to look at exponent rules, and we're mainly going to focus on the four primary exponent rules. But just as always, if you like this video, if it gives you, if it provides you with some help, it would be nice if you would like, subscribe, all that good stuff. So exponent rules. Let's start off with multiplying. And actually, I'll do this in a different color. So we'll start off with the multiplication rule. So let's say we're multiplying. And let's say I have x to the fourth times x squared. All right. Now, when I multiply exponents, the first thing I do, or actually let me back up. When we multiply two terms, or just two different numbers, the first thing we do if we have variables is we're going to multiply these coefficients. But if they're both just 1, then 1 times 1 is obviously just going to give me 1. Now, when we multiply the variables, as long as the variables are the same, which they are here, they're both x's, we're going to add their exponents. So in this case, we would say the answer to x to the fourth times x squared is x to the 4 plus 2. And 4 plus 2, I think we all know, is 6. So x to the fourth times x squared is x to the sixth. Let's look at a couple more examples. So let's say I have a to the fourth times a. Once again, when I multiply these variables, first I'm going to multiply the coefficients, but if the coefficients are just 1, then obviously I'm going to get 1 when I multiply them. So now a to the fourth times a, well, for a, I need to know what exponent does a have. And if it's not written there, it's just like if a coefficient is not written, we use 1 as the understood exponent. So what we're actually going to do here is say, okay, this is a to the 4 plus 1, which would give me 5. All right, so now let's mix in a few examples that have some variables. That way you can see, actually, let's just do one more real quick. So one more, we'll say, what about w to the 5th times w to the 19th? Let's try that real fast. Or actually, let's back up. W to the 9th. All right, so this would give me w to the 14th. Because once again, I would add the exponents. So when I'm multiplying variables, I add the exponents. And then let's work in a few examples with coefficients just so you can see. Let's say I had 3x to the 3rd times 7x squared. All right, so now when we're multiplying two different numbers, once again, you're going to multiply the coefficients first. So 3 times 7 gives me 21. Then you're going to multiply the variable. So x to the 3rd times x squared. Once again, your job is to know when you multiply variables, you add these two exponents. So we would say x to the 3 plus 5, which is x to the, or not 3 plus 5, x to the 3 plus 2, which is x to the 5th. All right, let's look at maybe one more, and then we'll move on from there. Let's say I have negative 8m to the 7th times 2m to the 3rd. So once again, try this one. So now we're going to multiply the coefficients. Negative 8 times 2 is going to give me negative 16. And then we're going to multiply m to the 7th times m to the 3rd. But since we have coefficients that are 7 and 3, we're actually going to add those. So we're going to write our answer as m to the 7 plus 3, which is m to the 10th. All right, so now let's move on to another exponent rule. And this one's going to be dividing. Let me find my examples. Okay, so now we're going to be dividing, and we have exponents. All right, so we have exponents and we're dividing. So let's start off with x to the 5th. Actually, let me move this over. For some reason it won't move. Okay, that's fine. All right, so x to the 5th divided by x to the 3rd. Now, whenever we're dividing exponents, we're actually going to subtract our exponents. So if I say x divided by x, they're the same variable, so we can divide these. Then I take 5 and subtract it by 3. So my answer is x to the 5 minus 3, which gives me x squared. All right, let's try a few more. So let's do k to the 12th over k to the 2nd. All right, now, once again, when we have variables that are dividing, as long as those variables are the same, we can subtract their exponents, and that gives us the answer. So k to the 12th divided by k to the 2nd is k to the 10th. And I bet you're probably picking up on this pattern a little bit quicker. So let's do a few more examples. Let's look at, how about we do an example with a coefficient. Let's say 6x to the 4th divided by 3x to the 3rd. Yeah. All right. So now, if we bring in coefficients, it doesn't really change anything other than we're just going to divide those coefficients. So the first thing I'm going to do is 6 divided by 3, which is 2. Now that I'm ready to divide the x's, once again, you're just going to subtract the exponents. So x to the 4th divided by x to the 3rd. And actually, yeah, that would be right. All right, so it would be x to the 1st. But x to the 1st can just be written as x. So 2x would be my answer. Let's try, maybe we'll try a couple more. Let's say we have, let's make this a little bit harder. 14r to the 2nd, s to the 2nd over 7rs. Now, all I did here is make this a little bit more difficult by adding in an extra variable. But I'll show you how to do it. So 14 divided by 7, that's the first thing we're going to do is divide these coefficients. Gives me 2. Now, an S and an R really can't divide. They can, but we can't really simplify it anymore. So when you are dividing, you want to make sure that you only divide the terms or the variables that are the same. So we're going to divide r squared by r. So we would say r squared divided by r. And we're going to subtract these coefficients. And if I know this r is just r to the 1st, that would give me r to the 1st, because 2 minus 1 is 1. So then I do that step, and I can get rid of all this that I've already multiplied, or actually divided. So now I can just continue going down the line and dividing my s's now. So if you have multiple variables, you basically just go down the line and divide those as well. So it doesn't really change a lot, but I wanted you to see this example just in case you ever see it in the future. So then s squared divided by s, once again, it's kind of like r squared over r. It's going to give us just s. All right, let's do, I don't know, let's do one more. Let's say 10x to the 5th, y to the 7th divided by 5x to the 2nd, y to the 4th. All right, try that one. So once again, first thing we're going to do is divide our coefficients. 10 divided by 5 is 2. Then we're going to get rid of those, and we can divide our x's now. Because once again, x and y, that's not going to be able to be simplified. So what we do is just rewrite our x's, or divide our x's. So x to the 5th divided by x squared. Once again, we subtract these two numbers. So 5 minus 2 is going to give us x to the 3rd. Then we get rid of those. And lastly, we're going to do the y's. So y to the 7th divided by y to the 4th is going to give me y to the 3rd because I subtract my exponents. All right, so now let's look at one more before we go to what I would call maybe the most difficult to understand. But before we get to that, let's look at, this is called a power rule. So we will write it, I'll just say exponents raised to a power. So it's basically like taking an exponent of an exponent. or raising an exponent to another power, like let's say we have x squared to the 8th. So you can see that what I did is I took this x squared and we raised this exponent 2 to the power of 8. So we're actually, it's almost like the exponent of an exponent. Now, when that happens, your exponent on the inside multiplies to your exponent on the outside. So this becomes x to the 16th. All right, let's look at a few more examples. So let's say we have m to the 3rd to the 7th power. All right. Now, once again, when I raise a power to a power, I take my two exponents and I multiply them. So this would give me m to the 21st. Like we can do another one. You could come up with a ton of examples for this. You could say x to the 5th all to the 2nd power. What's that going to give me? Well, I'm going to multiply the 5 and 2 and it gives me x to the 10th. Now, let's make this a little bit more challenging because most of the time they're not this straightforward. Let's say I have m to the 9th, n to the 5th, all raised to the 4th power. Well, that changes things a little bit, but once again, it's kind of like the division where we're just going to do each of these variables one at a time. So the first thing we're going to do is m to the 9th to the 4th power, all right, which that's going to give me m to the 9th to the 4th power. I multiply the 9 and 4, and it gives me m to the 36th. Now I'm going to do n to the 5th to the 4th power, and once again I'm going to multiply those exponents, so it's going to give me n to the 20th. All right, let's look at one more example like that. So how about let's say pq to the 5th all to the 3rd power. All right, now once again, if you have multiple variables and it's all raised to this power of 3, all the variables get that power of 3 if they're multiplied. And the p and q are multiplied together because they're right beside each other. So now this 3 is going to go to this p, which makes p to the 3rd. And then q is going to also get this exponent 3, but it's q to the 5th. So we're going to multiply the 5 and 3 to get q to the 15th. And that would be our answer. So now, let's factor in, or let's bring in some coefficients for this, because I've seen some people have trouble with this in the past, so I want to make sure you see it. 5x to the 7th, all raised to the 2nd power. Now, this can be a little confusing for some people, but here's what we have going on. Since the 5 and x to the 7th are multiplied, this 2 actually applies to the 5, so it would look like this, 5 squared, and it applies to x to the 7th squared. So if I really just broke it apart, here's how it would look broken apart. It would be 5 squared times x to the 7th squared, which, if we do those individually, 5 squared is 25, x to the 7th squared, once again, the power rule, which is actually what this is called if I haven't said it already, the power rule says if you raise an exponent to a power, you multiply the exponents. So 7 times 2 gives me x to the 14th, and that's just my answer. Like, let's look at another one just so you can see. Let's say I have 2x squared all to the 5th power. Once again, as long as this is just multiplication on the inside, then that means 2 gets the exponent 5, and so does x squared. So they both get the exponent 5. So then 2 to the 5th would give me 32. X squared to the 5th, we would multiply the 2 and 5 to give me x to the 10th. All right, so there's the power rule. Now, let's go to the last rule that we need to see. And this rule is called it's called a negative exponent rule. And let me actually find my notes. All right, there we go. So this is a negative exponent. Which? It all depends on, I don't know, it depends on what class you're in to know where this is covered. Sometimes people cover it in pre-algebra, sometimes it's algebra 1, sometimes algebra 2. So this can fit into a lot of different spaces. All right, so let's say I have x to the negative 5. Now, in math, it's usually a good rule of thumb to always make negative exponents positive. So you want to make these negative exponents positive exponents. So here's the rule. Let's act like this is a fraction that says x to the 5th over 1. Because remember, we can pretty much put anything over 1 as long as it's not already a fraction. So here's what happens to this exponent and the base of the exponent if I want to make this 5 positive. It actually moves its position. It's currently in the numerator when it's x to the negative 5. If I want to make this positive, then I take this whole thing and I move it to the denominator. So once again, if it's in the numerator and negative, you can move it to the denominator to make it positive, and then you could do it the other way. If it were in the denominator, you could just move it to the numerator. So I can rewrite this as 1 over x to the 5th, and that would make my exponent 5 positive. So let's look at a couple of those, because I think this is the hardest for most people, or the hardest example. So let's say I have, let's do x to the negative 2, okay? I want to make that exponent positive. So once again, an easy trick is you can put this all over 1, and then you can move the base of your exponent with the exponent all down to the denominator, and that will make it positive. So then I'm left with 1 over x squared. Now, we're going to make this a little bit harder for this next example, but I want you to work it, because a lot of people, the first time they work this, they actually work it incorrectly. So 3m to the negative 2. All right, try it real fast. Now, I'll tell you, a lot of people will write this answer and they'll say 1 over 3m to the negative, well, to the positive 2. However, that's actually incorrect, and I'll show you why. So, as I've been saying this rule, I've actually been saying something that's very important for this rule. Whenever you put this over 1, I've said, maybe for the past, I guess the last 2 examples, m to the negative 2, and I've said if I want to make that positive, I take the exponent and its base. Now, if I rewrite 3m to the negative 2 as multiplication, the base of this exponent is actually just the variable. So the variable is the only thing that moves to the bottom. So instead of moving 3 to the bottom, m to the negative 2 moves to the bottom, and 3 stays on the top. All right, let's look at another one, because I know that can be a little challenging. So let's say I have negative 7a to the negative 4. All right, now if I want to rewrite this as a positive or an answer containing only positive answers, here's the big trick. If I'm going to move this negative 4, I need to find the base of negative 4. And the base of that exponent is actually only a. It is not 7. So you have to act like there's a wall here separating negative 7 and a is the only thing that's going to move down to the bottom to make this exponent positive. So I would keep negative 7 on the top, and a to the 4th would move to the bottom. Now, you might be wondering, when will I ever need this? Well, let's look at a few examples. And for this, it's actually going to be a good review of all the rules, or some of the rules. Let's say I had w to the 7th times w to the negative 9. Now, this was the very first rule we looked at. We said when we multiply and we have variables that are the same, what do we do with the exponents? Well, we add them. So we would say w to the 7 plus negative 9, which is the same thing as saying w to the 7 minus 9, which gives me w to the negative 2. And what I've seen a lot is students will just say, well, there's my answer. But the directions will say positive exponents only. And if that happens, this would actually not be the correct answer. So let's look at how to make it correct. Once again, if we're using the negative exponent rule, we take the exponent that's negative and its base, and we're going to move it to, if it's on the top of a fraction, which this would be, it would be over 1, then we move it to the bottom of a fraction. So we would say 1 over w squared. And that would be my answer. Like, let's look at, let's say I wanted to do, let me find a good one for us. Let's just do one more. Let's say I wanted to do w to the, let's see, let's say I wanted to do 14w squared. Actually, let's make it just 14w to the third over 7w to the fifth. Actually, let's make it sixth. All right, so now, let's say I wanted to divide this. I'm going to divide 14 by 7 first. And once again, this is the, I believe this was the second rule we looked at. This was the dividing rule. So 14 divided by 7 is going to give me 7. Now, w to the third divided by w to the sixth, once again, that's the dividing rule for exponents, which means I subtract these. And if I do 3 minus 6, that's going to give me w to the negative 3. However, once again, let's say it said only positive exponents in the directions. Well, that means that my answer is not finished. So once again, what you have to look for with a negative exponent, you have to make sure that you find the negative exponent and find its base. And if there's a coefficient, you have to act like that coefficient's actually separate from the base. Unless there's parentheses, but I can show you that in a sec. But as long as there's no parentheses, you move only the variable with the negative exponent to the bottom of your fraction. So this w to the third would go down to the bottom, and our answer would be w to the positive, or 7 over w to the positive third power. All right, now, let me just show you this real fast. Like, on that last example, we said 7w to the negative third. I mentioned parentheses. Here's the only time that this 7 would actually move with the negative 3. If I said parentheses 7w all to the negative third, now that would move everything down to the bottom. But I doubt you'll see that. Well, you will definitely see it, but this video is more for basics, and that's more of an advanced step. So those are your exponent rules, and once again, you can leave a comment. You can try to message me or email me if you need any extra help with this, but those are the exponent rules.